Good evening, dear sir, madam, to one and all who present here. Respected Dr. Tommy Sebastian sir, our speaker of the day, our Dean Academics, Dr. Sudha Balagopal ma'am, our Academic Director Anil sir, our Executive Director Mohanendran sir. A warm welcome to one and all who present here for this particular meeting. I invite Sudha ma'am to say a few words about her.
A very good evening to everyone. It's indeed a pleasure to bid welcome to Dr. Tommy Sebastian, who is right now with us, logged in from Michigan, US. But before I proceed a little further, let me say a few words of thanks to Engineer Worky Luke, who was instrumental in giving us the contact of Dr. Tommy Sebastian. So the friends of Engineer Worky Luke, which happens to be my batchmates from Regional Engineering College, Calicut, are also logged in somewhere out there. Then again, my sister, that is Engineer Geeta Ramachandran, was also talking to. In fact, I hope she has influenced Tommy to be a part of this initiative. And Geeta, my sister, is also logged in somewhere there, and I believe she has passed on the message to several people. So they must also from her batch. So that batch of REC might also be logged in and waiting to listen to Tommy. Thirdly, the friends of or the batchmates of Tommy's wife, that is my brother's classmates, are also logged in. Another batch of Regional Engineering College, who will also be logged in and will be waiting to listen to Tommy Sebastian. So this is one part of the picture. On the other hand, we have our students, not just our students, students from various colleges, perhaps not just from Kerala, logged in and waiting to listen to whatever Dr. Tommy Sebastian has to say. We also have a lot of faculty members from various disciplines, our own trust members, which includes our directors, and very distinguished people, also waiting to listen to Tommy. So on behalf of everyone, all the batches of Regional Engineering College, our own college, and everyone here, it's my pleasure, and so with quite a lot of humility as also pride, let me congratulate Dr. Tommy Sebastian for having been awarded the IEEE 2019 Nikola Tesla Award, and he is the only person. He's the second person from India, and we are very proud of the son of our soil, that is of Kerala. And let me hope that Tommy hears a huge round of applause from various parts of the world in this particular achievement. Okay, so the applause is coming to you from various areas, various parts of the world, because people are logged in from various parts of the world. Moving on to what I wanted to say about him. Can wait a little, okay, a little more. Okay, so let me go to another aspect that I wanted to speak here, which is about the context of today. The context I will set in the sense that we are having a webinar series, and today we are going to have a keynote speech by Dr. Tommy Sebastian, who is an expert in particular areas of. In fact, he's a pioneer in the development of permanent magnet motors, and which has helped a lot in not just the safety but also the power steering of the electrical vehicle. So he might be talking about something in this direction today. Yesterday we had a youngster from New Zealand. Tomorrow we'll be having Gopi from Italy. I believe he is going to log in soon, because that's what he told me. Then we'll also have Nitin from Canada. He is also logged in, I believe. Then we'll be having Dr. Sethu from UK, but he must be doctoring now. He must be still attending to his patients right now. Then we'll be having Professor Amit Bhaya from Brazil. I believe the timing may not match a little, or he may be having other obligations, so he may not be here today. On the subsequent day, we'll be having Devika Chandramohan who again might be attending to classes, etc. Then we have also the final will be by Engineer E.P. Krishna Prasad. I believe he has been with us all through and he is also logged in. So this is the context that I would like to introduce again today. But regarding the theme I would say is related to what I heard yesterday while I was attending to a Facebook live session where one doctor was saying about this particular time, these extraordinary times when humanity is reaching out. I like those words, humanity is reaching out. And this is exactly what we are doing today. We are trying to reach out. We understand that quite a large number of people will be logged in today, listening to you, and we are reaching out. We are reaching out for the benefit of the students of today and the citizens of tomorrow, who should usher in a better tomorrow, And if that has to become possible, we must get the help of all you people out there, all you seniors who have seen the world, who have witnessed all kinds of engineering, who have experienced a lot of engineering, and who can definitely mentor at least a few students. So that's my first question. Is it possible for some of you at least to mentor a few students such that they do a better job at engineering? Second question that I want to pose before you is with respect to some of the companies that you are associated with. Can you give rise to some kind of collaboration such that a better engineering emerges as a result of this initiative? Third is, of course, the internships, the remote internships that you can offer in these times of lockdown when people are isolated and they are reaching out, and the reaching out is made possible via some internships, remote internships, okay, during these times. So, and finally, of course, collaborative projects are possible because our students are interested, our students are smart. Okay, I'm not talking about my students alone, I'm not talking about my college alone, but all the students in Kerala who would like to get your help, all these people, the seniors out there. So in this context, I hope that you will also hold on. The hand holding will be enabled by reaching out to us via the email address which Professor Anil will be writing down in the chat mail, which you can copy and to which you can respond, if not today, some other day. So this is one request that I have to place before you, all people out there. And now I will come to the informal introduction of Dr. Tommy Sebastian. I say informal because I believe after this, Professor Anil will read out the biodata that he has collected. So let me speak about how the whole reaching out happened to with respect to Dr. Tommy Sebastian. It was, as I said earlier, my friend, engineer Worky Luke, suggested this, and I was trying to connect to him. Okay, the international call was not being made, and then I received a call from him. This is what I call humility. It's not the person who is demanding, but the person who is giving, who is responding to a phone call. And then he talked at length with me, and based upon and he was trying to find out the kind of audience we have, the type of talk that he has to deliver. And I must really be appreciative of the greatness that he has shown in the brief intercourse that we had. Finally, moving on to the next step that I noticed was when I asked him for a biodata, he sent just a small paragraph about himself. Okay, so we say in Malayalam, Niragodam Tulumbil. I don't know if we have an English equivalent for that. That is exactly Tommy Sebastian. This is the Tommy Sebastian, Dr. Tommy Sebastian. The world has known, the world has acknowledged, whom we are introducing today in this session, and I believe the session will make him more clear to you. And I also hope that all the people who are logged in, they range from our patron, Engineer Ashokan PK, who is here, our executive director, and I believe many people from the trust is also here. I don't know if the principal has logged in. Anyway, many people from our side is here, and it becomes my sacred duty to accord warm words of welcome to not just Dr. Tommy Sebastian, but all the REC people who are here, all the friends, all our friends from different parts of the world, all our trust members, all our faculty members, all our dear students, and not just from our college, but from also outside colleges. And with these few words, let me conclude my duty by saying that Anil will now make the formal introduction. Thank you.
Thank you, ma'am. Thank you so much. Next, I invite Dr. Deepa Mohan, Professor, Civil Engineering Department, to introduce the guest, Dr. Tommy Sebastian, sir. Deepa, ma'am, please.
Good evening, one and all. I take this opportunity to welcome and introduce Dr. Tommy Sebastian to this e-gathering. Welcome you, sir, to the Vidya family and also to this e-gathering. Let me introduce you, sir. Dr. Tommy Sebastian received his BSc Engineering degree from Regional Engineering College, Calicut, presently known as National Institute of Technology, Calicut. He took his MS degree from Indian Institute of Technology, Madras, MASc and PhD degrees from University of Toronto, Canada. He worked with R&D Center of Keltron, Trivandrum, Black & Decker Corporation, Baltimore, USA, Delphi, Saginaw Steering Systems, and Next Year Automotive in Saginaw, Michigan. Currently, he is the Director of Motor Drive Systems at Hala Mechatronics in Bay City, Michigan, USA. Dr. Sebastian has done extensive research in the area of permanent magnet motor design and control issues and applications in steering systems. In 2003, he was elected as a Fellow of IEEE. He is the recipient of the 2019 IEEE Nikola Tesla Award. He was the General Chair for the first IEEE Energy Conservation Congress and Exposition IEEE ECC 2009 held in San Jose, California. During 2017-2018, he served as the President of the IEEE Industry Application Society. I welcome you, sir, once again to our Vidya family and to this e-gathering, sir. Thank you, sir.
Thank you so much. Let me get my presentation shared.
Let us know if you need any help. Okay, please let us know if you need any help.
No, I think I'm all set. Can you see my screen?
Not yet.
It has to cross the oceans to get there.
Yeah, that's right. Yeah, it has to cross a lot of oceans. Yeah, no, it's okay. Yeah, I think you're slowly making connection.
Okay, by the time it comes up, first of all, thank you so much for giving me the opportunity to spend some time with you all. I did not know that Sudha has arranged REC alumni also along with this. When I talked with her, she said it is the students now. I know that we have an REC get together also here. But anyway, that's great to see that. Is the slide up already? Can you guys see it?
Can anyone see the slide? I don't see them.
Yes, sir.
It's okay. Yeah, perhaps I have to pin. Do I have to pin? Yes,
Okay, I'm hoping that most of you can see it. So let me continue then. Yeah. Again, thank you. And I work here at a company called Hala Mechatronics. We work with the motor and motor control issues for automotive applications like steering, braking, and propulsion, and so on and so forth. So that is my background here. But I probably will not be covering too much technical details here, as I know the audience is pretty diverse group of people. If I start talking too much about the electrical content, maybe I will lose half of you. So I will just keep it more general in terms of what is happening in the automotive sector in terms of electrification and electrification activities. So that's what I will cover today. Before I do that, I don't know how much time it takes the slides to change. I hope you see a new slide yet.
Yes, sir.
Yes.
Okay, good.
Slide.
Hopefully it's changing quicker than the first one. So I look. I mean, if you are sitting in a Cochin or a Trichur, we are just the other side of the globe, and we are sitting in the northeast part of United States. And if you go a little further, we are surrounded by the Great Lakes, the 5 Great Lakes, which we have probably studied in the preschool, in the elementary schools and high schools. The largest freshwater lakes in the world, the 5 lakes, are pretty much surrounded by us here in Michigan. And you can see the New York is here, California is all the way west here. It's way outside the scale here. So, but when we talk about the electrification, I think there's one important point here is the first hydroelectric plant was built in Niagara Falls in 1881. Niagara Falls is really a waterfall from between the 2 lakes, the Lake Erie and Lake Ontario. So that's where the Niagara Falls is, and the first hydroelectric plant was built in there. So the line you see is actually the border line between Canada and the United States. So that's just the background. So Toronto is just north of that line, basically. You can write somewhere here. Okay, with that, let me ask you the question, how many cars are running in the world? If you look at the whole world, we have about 1.4 billion cars are running around the globe. Now, out of which, when we talk about electrification, I think most of your thinking is electric cars. But if you look at the electric car market at the same time, now this is about 3 million cars, or 3.2 million cars in 2018. I think we had another 2 million, less than 2 million sold in 2019. So we are about 5 million cars, probably pure electric vehicles on the road. So if you look at the percentage of the cars which are really electric cars, it's less than 0.5%, or it's 0.12% in 2018. Probably it's a little more in 2019. So the point I wanted to just make was, vehicle electrification is more than the electric vehicles. It is the cars are becoming more and more electric, even without the electric cars. So if we look at the first mass-produced car, it was the Model T from Ford. It looked something like this. It was introduced in 1907, 1908, I think, the first car. And at that time, the electrification was very minimum. There was a 6-volt battery and a dynamo to charge the battery and a couple of lights, and that was the extent of the electrification in that car. In 1950s, the 6-volt battery became 12-volt, and even today, most every car has a 12-volt battery in that one. But during that time, actually, from 1908 to 1925, they sold about 15 million of these cars around in US. But from that 6-volt battery, today, if you take the car, there are so many things which are controlled electrically. Look at the I mean, all the navigation systems, all the human machine interface for the entertainment system. Electric power steering is one area which I will talk a little more later. The ABS, anti-lock brake systems, regenerative braking system, tire monitoring systems, electric water pump, cabin heating, even automated or heating of seats and steering wheel, electric air conditioning. And as we go into the electric and hybrid cars, the hybrid controls, the motor controls, the motor, the charger, inverter, all that stuff is coming into the car. So the electrification and advanced control in the vehicle are accelerating at a faster rate, irrespective of the electric vehicles. Now, why is electrification important? Is it all we electrical engineers like it? Is that the reason why we are going with electrification? I categorize it into 4 reasons, being mainly one I put at the top is the safety of the vehicle. And the second one is the fuel economy and emissions. People are really concerned about all the emissions and the depletion of the gas, petroleum, and diesel availability. And of course, the next one is the driver comfort and convenience. So let's take each one of this one. If you look at the safety of a car or of a vehicle, today, if you get into a car, you have the seat belts and the airbags and all that stuff in the car to protect you in case of an accident. So these are actually passive safety systems in the car. This will help you only if you have an accident. Now, the next generation is really asking the question, can we avoid getting into the accident? So the avoidance is the next level, and the passive avoidance systems are mostly for giving warning to the driver in terms of avoiding the accidents. For example, if the system can monitor the driver eyes and see that the driver is sleeping, so then you can warn the driver by maybe shaking the wheels or seats or something to wake him up. Or if you're going on a highway and if you're drifting from lane to lane because you are feeling sleepy or something, the car can bring it back. The car can give warning to the driver, and the driver can bring the vehicle to the safe level. So these systems are actually in the market today. Quite a number of cars have these features where the car doesn't actively avoid the accident, but the car helps to avoid the accident by warning the driver early enough. Now, so that is where we have today. The next generation is actually more active safety, where the car now starts doing things to make the car more safely. For example, we have what is called the adaptive brake cruise control with braking, where if you are going on a highway at a certain speed in a cruise mode, and if the car in front of you slows down, your car automatically slows down without you intervening in that one. So now these are the fundamental elements of the safety, active safety systems you are seeing in the car today. Again, even that is in the car today. Now you can extend this much further to say that, okay, if your car is going to roll over, can you do something actively without the driver's knowledge to make that car safe? And these are the type of systems which we can expect in the future. But now, when we talk about when you talk about, you hear a lot of talk about the autonomous driving and autonomous systems, and in such systems, these active safety systems becomes important and important factor in making that systems a reality. So you will see more and more of active safety systems in the car. Now, all these active safety systems in the car are possible only because of the added electrification in the car. Let me so in all these things, you are probably have seen at least some of these type of situations on the roadside, and the next generation cars, the electrification activities which we are doing in the car is all enabling us to put an end to this scenery on the roadside, and being able to minimize or eliminate as many accidents as possible by the car actively getting involved in the safety activities. Now, so let's talk about some of the fuel emission activities. So the first one I should say is the steering systems, which I worked on for quite a number of years. When I started working on the steering activity, at that time, every car you buy had what is called a hydraulically assisted steering system, in which you have a pump, and you pump the high pressure fluid into a piston and a cylinder arrangement, and when the driver turns his steering wheel, a valve mechanism opens and push that high pressure fluid into a chamber, to a piston, so that it helps the driver to steer the car easily. So this was the situation maybe 20 years back. But today, if you buy a car, you are most probably buying a car with electric power steering in that one. So we replaced all the hydraulics and everything with an electric motor control, and a sensor in the vehicle. So this transformation was really I was lucky to be a part of this transformation from the hydraulic to electric power steering. And now you asked, I put this under the fuel economy condition, but really speaking, the fuel economy is coming because in a hydraulic system, the pump is connected to the engine all the time when your engine is on, so it's producing losses all the time. Whereas in electric power steering, the loss, when you're not steering, the motor is not doing anything and not taking any current. So the net energy saving from converting from the hydraulic steering to electric power steering is anywhere from about 0.5 miles per gallon to 2 miles per gallon, depending on the vehicle. So this introduction of the electric steering saved billions of barrels of oil for the auto industry. Now, of course, another good example for the electrification is the electric cars. In the electric cars, you have the battery, the motor, the controller. I mean, it's pretty much, we eliminated all the IC engines and all the hydraulics. Pretty much everything is gone, and all the control is now handled electrically. So huge movement in the electrification. Now, when we electrical and mechanical engineers, we are proud to say, they talk about our design of our motors and our power electronics and all the stuff, but really speaking, the common man doesn't care about all that stuff. They want to make sure that when they buy a car, they want to be able to transport their stuffs comfortably and conveniently and everything. They don't want the car taking up all the space for the motor and engine and everything. So this picture is the picture of a Tesla car. Now they have replaced the engine compartment with the luggage space, and you can see that the front cabin, where used to be the big engine, is now really the luggage space. Now it is for us engineers to decide, how do we manage, how do we package all this electric electrical stuffs which we like into a space where nobody can even see it, and package it into a very small space. So the design, so that brings up design challenges for us in terms of, how do you make these things more smaller and package it smaller. When you say package it smaller, also means you have to minimize the power dissipation so that you can manage the heat properly too. So as I said again, we are saying that we don't have any space for packaging motors and controllers and everything. So we have to find spaces where nobody can use it for other purposes to package all these things. So this is a good example in terms of how do I package the motor and control inside the wheel, so that this space is actually not being used for anything else. So can I package all the motor and controller inside the wheel so that in-wheel drive systems can be implemented and all the engine space can be used for something else. So there are a lot of work going on in this direction, but nothing is in production yet. So you will see more and more of this type of activities going on, and hopefully sometime in the future you will see that in the market too. Now, let's talk about the driver comfort and convenience aspects. I think when you talk about driver comfort and convenience, the first thing probably you can think about is the autonomous driving cars, where the driver can do whatever you want. The car drives by itself. It's very convenient for the driver, and the car can park automatically, car can find the parking space automatically. All that stuff becomes important in terms of the driver comfort and convenience. Now, few things which you probably have seen some of the things, hail, robot taxi. Singapore has started testing robot taxis a few years back, and they're still working on that. And few other things, electric air taxi flies over Singapore. Again, electrification is not just in the vehicle, even the planes are all moving towards the electrical things. This is a couple of weeks back from IEEE Spectrum. Can cargo carrying drone jump over air freights? The drones, electric drones, can carry stuff from the ship to the places and things like that. Conveniently, you can use the electric drones for that one. An inflatable e-bike fits into a backpack. And again, it's from IEEE Spectrum last couple of weeks back. So these are all electrification of the vehicles and the electrification of all the personal movement equipments. Now, when we talk about all these things, we have a lot of challenges, and many times there is a challenge. It's an opportunity for all of us. Now, when you go into the pump station to pump petrol in your car, have you ever thought about how much power transfer you are doing? Let's take an example. The gasoline has approximately 32 megajoules per liter of energy density. Now, let's assume that now you have a tank of about 50 liters, which is probably a small car. So if you talk about the total energy you are transferring when you're pumping the gas or petrol is about 1600 megajoules. And let's say you are taking about 2 to 3 minutes to pump that gas. The energy divided by time is the power, and you can see that it's an 8.9 megawatts of power. So you don't realize that when you're pumping that petrol, you are putting an 8.9 megawatt power transfer to your car. So it's if you think for electrical people, if you want to think about it, if you have an 11 kV line, let's say it's for the sake of simplicity, a single phase 11 kV line, you need to take 1000 ampere from that to get to that power level. So if you convert that into electrical power, you are talking about a huge power transfer of 8.9 or about 10 megawatts of power. Now, if you look at the electric car, I took an example of the Tesla Model 3. It has a battery capacity of about 85 kilowatt hour, which converts it into about 306 megajoules. So if you want to charge, of course, this megajoules is much lower than the 1600 megajoule we saw for the gas, because of the IC engine efficiency is much poor compared to all the electrical efficiency. So you can get the similar ranges with much less energy from the battery side. So this battery probably gives you roughly in the same miles range compared to the 1600 megajoules of petrol. So when how do you charge this battery? So if you want to get the same performance like a gasoline, you're talking about charging with an 8 or 10 megawatt charging system for the car, which is not very easy to accomplish. So I put a charging power on the x-axis versus the charging current and the time required for charging the battery. Again, assuming the same Tesla 85 kilowatt battery at 375 volts, you will see that now as the charging power goes up, your current starts going up and the charging time goes down. So most of the electric cars comes with its own charger, built-in charger, which we call it as a level 1 charger, which is somewhat about less than a 1.5 kilowatt type of charging system, which can be plugged into your home. So most of that stuff, most of the charges takes several days really to charge the car. So you can see that about 6,000 minutes is about 100 hours of charging to get there. Now, so this is what is coming in the car with the charger, which you can plug it into the car, into your home. Now there is another level of charger you can buy outside. We can charge it from outside, which is we call it the level 2 charger, which is about 3 to 20 kilowatt charging. This will bring it down the charging time to overnight or even a day type of charging. You can bring charging time for these cars. Now the next one is called the level 3 or the supercharger, which is about 100 to 150 kilowatt type of numbers. And here you can charge the car at least in about 30 to 40 minutes type of timing. You are able to charge the car. Now, so even with this superchargers, which is about 100 to 150 kilowatts, now think about a gas pumping station to be replaced with an electric charging station. If you are 10 cars pumping or charging, you are still talking about more than 1.5 megawatt of power transfer again there. No. So how do we manage all these charging centers and charging time, and what is its impact on the power system? Even for commercial power systems, like big companies have their own internal power systems, and these companies are now will have to support the employees, and they have to provide charging stations. So how do they all manage? Is the electric vehicle making an impact on the net emission? That is another big aspect. Also, people say that electric vehicles bring down the emission, but if the source of the power is coming from coal and gas, then you are really transferring the power, the emission from one place to another place. Whereas if the power grid is mostly renewable, then that makes a difference. So these are the other thing is this huge load you're changing suddenly on and off from the power system, and the load fluctuations due to EV charging has to be managed by the power system. So there are a lot of challenges which are coming up because of all these things. Now the other big challenge is really the battery. Battery is one of the weak point in the electric vehicle infrastructure, because the size of the batteries and the cost of the batteries are two important factors. If you take the electric vehicle today, the biggest cost in the electric vehicle is in the battery. So today we are sitting somewhere around less than $200 per kilowatt hour, and the expectation in the next 10 years is to bring it down to about $60 per kilowatt hour. Now A lot of research is going on in the battery technologies, and you will see improvements in the batteries. Now, even if you come up with an ideal small battery, charging will be still a challenge because of the reasons I explained before. Now, how do we transfer the power to the battery? Now, there are, especially in the automotive systems, there are a lot of important considerations and challenges. You can make all our bells and whistles if it is more expensive, and if it is very expensive, nobody will buy it. So cost effectiveness is a huge huge factor in terms of making all these systems viable in the real life situation. I know when we were working on the electric power steering in the beginning, the biggest challenge was one of the biggest challenge was the cost, and the other one was, of course, the performance in terms of the torque pulsations you see from the motor. How does it come to the driver on the steering wheel? So these were some of the challenges we had in developing the electric power steering. Now, smaller packaging and higher efficiency. As I said, cars are not made for transporting power electronics and motors and things like that. So we have to package all these things into small area. And one of the biggest factor in packaging that, especially with the power devices, is the higher efficiency. If it's producing a lot of heat, then you have to manage the heat. So it becomes difficult to package into small spaces. Now, I talked about the autonomous driving and autonomous systems and highly safety critical systems. The fault tolerance and diagnostics becomes very important. I'm showing a picture on the right side here. This is actually the power electronics controller for a steering motor, which is in production today. This is you can see the size of the controller with respect to a pen there. This is actually a redundant system in the sense that these are used in a car where they have the capability of autonomous driving. So that means when you have autonomous type of systems, a failure is not an acceptable situation. So in case of any failure, you have to have redundancy. So you can see in this one, you have actually 2 microprocessors and 2 power electronic devices. Everything is duplicated so that in case one side fails, you can take care of the system with the other side. So this is the trend we are seeing in terms of all the fault tolerances that is needed for the next generation of autonomous type of vehicles. And as I said, the fail-safe and redundant operations, and other couple of things is the audible noise. And audible noise is really critical in automotive applications because, again, if I talk about steering, when you steer the car, you don't want to hear noise of the motor. So you have to make the system much more no noise, audible noise coming out of there. And of course, the high temperature operation is also required. Under hood, you can expect temperatures much more than 100 degrees C. So the electronics will have to be able to survive under that temperature. Now, if you think about, why are we talking about, you saw what are the benefits of the electrification. Now, why are we talking about all these things now? Why didn't we talk about this 20 years back? I think the critical reasons are really one of the major thing is the significant improvement in the power electronic capability. For those who are not familiar with this one, the MOSFETs are the power electronic switches which you use for switching high currents. And these switches have become very highly efficient now. Previously, when this MOSFET is conducting, there was conduction losses. Even now there's conduction losses, but the losses are so low. The devices which we are using is 5.5 milliohm type of MOSFETs under on condition, which means it is just like copper wire. So So the performance and the cost has come down significantly. And for high voltage type of devices, the new wide bandgap devices which are going to replace the MOSFETs are the gallium nitride and silicon carbide devices are getting a lot of traction in terms of its applicability into, especially into the electric vehicles where we have high voltages. Now again, these devices give opportunity to minimize the losses and improve the efficiency, and so that you can manage the heat much better. So, and today they are a little expensive, but I think as time goes, the cost will come down. And the performance and cost of low loss wide bandgap devices, the cost is significantly coming down, and I expect that it will come down still further in the next few years. And another big factor is significant progress in the processing and control capabilities. I talked about the safety implementation of safety systems where, if the car is going to roll over, you can take action to control the vehicle to safety, which means that, the car has to have sensors to sense all the activities, and we have to be able to process and do the analysis and make the corrective actions in a few milliseconds probably. So the computation capability is all required to be done in very high speed, and today's processing capabilities are allowing us to be able to do that. As when I started working on the electric power steering, first systems we were using an 8-bit processor, which has very limited capability, whereas today with the digital signal processors, we are able to do even complex calculations in very small time period. For example, if we want to do a very complicated flux vector control of the motor, we are able to do that all in a short period of time with the today's processing capability. And of course, the reduction in electronic cost is now allowing us to use all these things in the car. If it's very expensive, nobody will buy it. And there are a lot of developments in the electric machines and how it is manufactured, and the manufacturing costs have also come down because when we started talking about brushless motors several years back, you are competing with a brush motor, which was a mature technology, and it was always more expensive. Now today, the manufacturing techniques and all that stuff has come a long way to be able to compete with that in terms of cost. And another thing is the efficient analytical tools for design optimization. If you look at the motor design and all that stuff, we are able to analyze all the flux lines, where it's going and where it's concentrating, so that we are able to take out all the unnecessary steel, so that we can minimize the weight and size of the motor. So this type of analysis tools were not available several years back. Today we are able to do this optimization very well, and able to minimize the size and cost of the system. So these are all enabling us to put all these things into the real life applications. Now, I just want to spend, because I'm sure in the audience, you have different types of engineers in terms of electrical, mechanical, chemical, or even in electrical, if you have power electronics, machines, sensors, smart control algorithms, advanced control systems, motor designs, communication systems. We talk about autonomous systems and everything. Communication becomes, even when we talk about the computation, we said we have to have the sensor information coming to the processor. How do you communicate between the sensor and the processor, and how fast we can do all these things? So fast communication systems are all required, and software is one of the huge factor in the cars. I think the number of lines of code in the car, in the software, in terms of the software, is today order of magnitude higher than what was in the first Apollo mission into the moon. So the the software content and the significance of software and the safety associated with software, because we cannot afford to have bugs and faults due to that. So that they are all becoming very important, and there are stringent rules and regulations in place to make sure that the errors are not possible or minimized in the software. So we as different types of engineers will have to close our eyes in terms of thinking as focused engineers rather than, and start thinking as systems engineers. And we need to integrate all these things to make the final system viable. If you work as a power electronics engineer without knowing the system, you are not going to be successful. So you really have to understand the system before you can start designing your subsystem. So we all have to become a part of the systems engineer to be able to make the system capable and usable to the final user. So the systems approach is very necessary, but at the same time, I also have to say that, especially for those who are in the undergraduate students who are listening to this one, the basics and the fundamentals are essential to build on top of that all these systems. If you don't have your fundamentals and basics clear, it's very difficult to build it on top of it. So the education you are getting in the school right now is absolutely necessary, and also you can see that the electrical engineers takes mechanical engineering courses and the other civil engineering courses and things like that. They're all required to understand the system for us when we are finally in the real life application area. So this basic understanding is needed to build whatever you want to build on top of it. So to conclude, I really want to say that last 20 years have witnessed tremendous progress in communications and medical advancements and transportation systems and social media and all that stuff. We have seen so much of improvement. I mean, when I was at IIT Madras several years back, and I got admission to study in the University of Toronto in Canada, I had to make a phone call to the university. I had to wait in the IIT telephone office 3 nights to make one phone call, because you have to book a trunk call to first, and then you wait there until they give you the opportunity to talk. So I had to wait 3 nights finally to get it connected. Today, I am sitting in US and talking to all of you in a bidirectional way. You can talk to me too if the organizers allow. So we are able to come to. I mean, I couldn't even imagine that that time that we will be able to do this today. And similarly for several other technologies, what we couldn't even think of 20 years or 30 years back is all becoming reality today. So what's going to happen in the next 20 years? In my mind, it is a good time to be an engineer here, because we can be a part of the next generation of technological revolution, and it's a great opportunity for all of us. And I think it is up to all of us to define how will it look in the next 20 years. So it's all of us to define it, and I'm sure some of you listening to this one will, or most of you who are listening to this one will be a part of that next generation revolution, and I wish you all the success in that one. So with that, I will conclude here, and I'm hoping that I didn't take too much time than what I promised, but I would like to give opportunity to answer some questions. Let me stop sharing this one. So
good evening again. Okay, I think you will be addressing a few questions, because the whole presentation was, I believe, understandable to all the kinds of people who are listening to you. In fact, it was as interdisciplinary as is possible, and I found the presentation very simple And I'm hoping that there'll be questions, because I have a couple of questions, but I'm waiting for the students to say something, or the people. Okay, the other people maybe ask something. Okay, somebody, yeah, Vivek is ready to ask a question. Yes. Okay.
Sir, the presentation was very good. Actually, it was very informative also. I have a question. Sir, can you hear?
Yes, I can hear you. Yes.
Yeah. I have a question from user point of view. I'm not asking this from a researcher point of view. What's the solution for range anxiety in electric vehicles? Because practically we have infeasibility regarding the range even now. For example, the maximum range for an electric two-wheeler in the Indian market is still around 100 kilometers. And we have no swapping option for batteries. Most of the vehicles have no portable batteries. Some vehicles have, of course. And if at all we are going to install swapping stations, different vehicles have different types of batteries. So can we install stations which are suitable for all these types? That is two aspects of the question. And one last thing. Most of the electric vehicles which are good quality electric vehicles, they charge a monthly amount for their cloud data service and monitoring, which is mandatory. We have to pay that. So finally, the EV application has been limited to short distance travels, at least in India. So unless and until we see a revolution in the material side, can we expect the emergence of EVs in large scale or rather for long distance applications?
Okay, I think there's a lot in that question. Let me first tell you that we are, as I showed you in my first graph. Now, electric vehicle is very much in the infant stage now. In terms of the number of vehicles in use. So the first thing you need to understand is in order for the electric vehicle to become more viable, you need to have an infrastructure of charging. I mean, today, don't you have, when you drive your petrol or diesel car, don't you have the anxiety for fuel finishing? But you are addressing that today because you know that there is a pumping station in the next 2 miles or 1 mile or 3 miles. So you are comfortable to take that risk today. I think we need to come to that level. In order to get to that level, the infrastructure has to develop, and we are not there yet. But if you look at in US and how is Tesla managing that is, if you buy a Tesla and they have placed their charging stations on major highways at distances which are manageable. So, and the driver, when you drive the Tesla, it gives you warning, you have only this much of range available, and your next station is here. You need to pump it. You need to charge it there, and so it gives you the warning today. So that is how Tesla is addressing the range anxiety issue now. Now, this as time goes, as more and more infrastructure got built, I think it will become a standard for everybody that it's becoming an acceptable phenomenon now. Today, you are absolutely right. We are nowhere near that. So you will be scared, especially if you don't know where is a charging station. I mean, again, Tesla, what they're doing is, they have all the communication systems inside the car so that they exactly know which locations are the charging stations. So the other thing is you talked about swapping of batteries and the other area. There needs to be standardization for the charging, and everything needs to happen. That is one area which will require some of we engineers to develop the next generation standards so that any vehicle can be charged or even if it is swapping battery, all these things can be accomplished. So again, these are all the work that needs to happen in the next few years to support the development or to support the usage of the electric vehicles in the real life.
Thank you, sir. Thank you. Thank you,
Dr. Thomas Sebastian said, this is a wonderful time to be an engineer. Okay, Vivek? It applies
yes.
to you.
Yeah.
It applies
Yeah.
to all the aspiring engineers. It is definitely a wonderful time to be an engineer. Quite a lot of hope for. There's a lot of space for development. Okay, and this is exactly what he said in his slides, as also right now.
Yeah. Thank you. Thank you.
Hello.
Yes.
Sir, my name is Ish. I'm from a student of Academy.
Oh, you are breaking off. I cannot hear.
That's a student. I hope I'll go. Imish, go ahead.
Yes. Hello.
I cannot hear. I don't know if you guys can hear there. If somebody can hear it, if you can tell me again, I can answer that.
Sir,
Speak near to the mic if possible.
Sir,
We are not able to hear you. Can you please chat the query?
Yeah, maybe we can put in the chat so that we can see. Yeah. In the meantime, if somebody else have a question, we can.
Okay, Tommy Sebastian sir, first of all, let me congratulate you for your groundbreaking research and innovation in the permanent magnet synchronous motor drives. It is indeed inspiring to us young engineers as well as researchers, and it has been my privilege to attend your talk. I have just a quick question, which is pretty general. Since you are being closely associated with the automobile industry, I was curious, in your view, what are the real challenges? Is it the technological or rather the policy and regulatory challenges which are a big hurdle for the mass scale deployment of electric vehicles?
Okay. I want to stay away from the political side in the discussion, but I think as engineers, we need to focus on the technological challenges, and associated with that is the cost is. I mean, governments can give subsidies and all that stuff, and that cannot last for a long time. We have to make the systems cost effective, and we have to minimize the system cost so that without government support and everything, we can survive. I mean, that is we engineers has to take that as a challenge and say, how do I make the system more cost effective so that I can sell the electric vehicles? So that is our challenge. And of course, this is chicken and egg also. Us, we are competing with a very mature technology, and we are coming up with new technology. And it takes time to develop that and to bring down the cost. And I think that is the issue. So it takes some time, but if you look at, again, I take Tesla as an example. Their first generation cars were all selling for nothing was sold for less than $100,000, but the Model 3 is now selling it for about base price. I think it's about $30,000 or $35,000. So that's a leap change to be in terms of who can afford that car. So it's coming down, and you will see further reduction in price as time goes in the next few years. So then it becomes more and more feasible for people to buy it.
Thank you, sir.
Now,
Amish has written in the chat that is there any gear system in electric vehicle? He has also asked that if we use the in-wheel motor in the front wheel, how can we turn the vehicle? So these are two questions that they put in the chat.
Let me. Is there a gear system in the vehicle? In the most of the vehicles we have today has one air gear system, which is a fixed gear rather than changing the gear, so that the electric motor can be run at much higher speed. The reason why we do that is the motor size is proportional to the torque. So if you want to directly couple the motor to the wheel. So your torque has to be much higher, so the motor size goes up very high. So that is the reason why, to minimize the cost of the motor, is the main reason why we are using a gear in the electric vehicle today. Now, what I said just contradicts with the in-wheel concept. The in-wheel concept, you are putting the motor directly in the wheel, and there is you still can put a gear reduction, but normally you want to avoid that gear reduction there because you don't have space for all that stuff. So but the advantage there is, you have at least 2 wheels or 4 wheels to put the motor, so you're splitting the power into 2 or 4 wheels, so we are able to manage that one. So still it's a challenge. Again, as I said, these are the challenges for us engineers to take up and say, how do we address that? So the main reason for the gear is to minimize the size of the motor. And I don't know what you mean by turning the motor. I don't know whether he's talking about the steering. Yes, yeah. You can still steer because it is going to be steering on a suspension, and you can still steer the car. And finally, the objective is to see whether we can incorporate the steering and the braking and the propulsion all into that modules. We call it as a corner module. Yeah.
I think here. Thank you.
Any other questions?
Anjali wants to ask something. Anjali, do you want to ask something? Anjali, are you asking something? Your mic is on. Okay, she has switched off. Okay, so can I ask a few questions right now?
Yes, sir. Sure.
Of course, what's the role of flow batteries now? Because flow batteries are coming up, and everyone is still talking about lithium-ion batteries. Can we start thinking about flow batteries? Because it looks appropriate for electric vehicles. So that's question number one. Question number two is, why do we think about the same kind of shape for the cars? Why not a three-wheel car? Because then all these, what Emesh said right now about turning the wheel, etc., becomes easier, isn't it? Like an auto rickshaw that you see in Kerala.
I'm sorry, I didn't get that. How do you make it?
First question, that is what do you say about flow batteries? What do you say about flow batteries? The possibility of flow batteries instead of lithium-ion batteries, because flow batteries are coming up in a large way, and I believe it looks somehow suitable for electric vehicle. That's question number one. Question number two is, why do you think about the same kind of shape, the same number of wheels, etc., for electric vehicle? Why not think about a dramatic change in the complete construct of the electric vehicle or car?
Okay. First, the battery.
That's a question in fantasy.
Yeah. First, the battery side. If you look at all the articles which are coming out these days, look at the spectrum, IEEE spectrum coming out just yesterday. July. There's a lot of articles about the solid state batteries and all that stuff. But it's not only lithium ion, lithium sulfide. There's so many different technologies coming up, and I'm not an expert in any of that stuff, so I don't want to make and say that no one is better than the other. But I see that the amount of work going on in each of the battery areas will create developments to minimize the size and cost of the batteries. I think it is imperative that it will happen because of all the work which is going on. But I don't know which technology is going to win at the end of the day. The time will tell that one. The second question was the construction or the implementation of how we can all come up with ideas. I go back to the Tesla as the example. GM came up with the first electric vehicle in the end of last century, actually in the 1990s. They came up with the first electric vehicle, a production vehicle, but it didn't go anywhere. And people were all skeptical that no, electric vehicles are not going to go anywhere. And Tesla said, we are going to start electric vehicle market, and everybody laughed at it. Okay. Now look where we are today. We are all talking electric vehicles only because of Tesla in my mind. So the Elon Musk, who is the chief of Tesla, is somewhat of a crazy guy. I would say once he has the idea, he will develop that and implement that. And he started SpaceX and put the transportation system from here to the International Space Station. So this is an example of what you can do if you have a will to do it. I think we all have to learn from that. So if you say that, there are other ways of doing it, if somebody can see the advantage and implement it, it can happen, it may happen. But again, you have to understand what are the value systems we are providing. At the end of the day, somebody has to buy it, and what is the value we are providing to the final user. And if you are clear on that one, I think we can make anything happen.
Yeah, that's a very good message. Minimization is definitely going to be the mode of the day. I believe there are a few more points in the chat. One is a question: which type of electric motors give better efficiency? Your area is perfect. So if you can,
I may be biased on that one. The magnet machines are the most efficient machines available today. Now, see, the one of the things which we have to keep in mind is, every machine has its own natural characteristics. When you talk about efficiency, you're only talking about one point, but most of the time, any motor you take, especially the variable speed motor, doesn't operate at one point. It operates at different speeds and different torques and everything. So when you talk about efficiency at one point, which is the maximum efficiency point, has really no meaning in terms of the real life application. So let's assume, take the case of a switch reluctance machine. If the characteristics of the speed torque characteristics which you need is ideal for the switch reluctance machine, and if you don't care about the noise produced by that machine, maybe that is the best machine for that application. Okay, so I should not say that one machine will fit all applications for all reasons. So each application has to be looked at carefully. Again, you need to look at and say, permanent magnet machine, when you say that, that is the best machine, but it is more expensive because of the magnets you are putting it in. Okay. So now, are you ready to pay that money to get the extra efficiency? Do you get the value out of that one? If you don't care about that one, why spend the money on that one? Spend the money on something else and use that one. So it is not that, even though when I say that the permanent magnet machine is the best one, I wouldn't say that is the best machine for all applications. There may be other types for other applications.
Even brushless DC motors are now permanent magnet motors. So perhaps
brushless DC is a version of the permanent magnet machine. Yeah.
And moreover, permanent magnet machines lifetime is an issue, isn't it? Life.
No, actually, permanent magnet machine, the lifetime is not an issue.
Better?
No, it is. Based in the permanent magnet machine, if you take the machine, the only mechanical part is the bearing. Okay, so if something is going to fail, probably it's the bearing which is going to fail first rather than failing anything else, as long as you make sure that the machine is operated within the allowable range, because permanent magnet machines can demagnetize if you put extra over current into that machine. So you need to make sure that under all conditions, you are not putting that extra current into that machine, especially at high temperature with neodymium type of magnets, because at high temperature, these magnets demagnetize easily. So you need to make sure that you are operating within that range. If you can guarantee that, then there is no need to worry about that. We have put millions and millions of motors in the car. We have had very little returns of any issues like that.
Okay, that's a big point in favor of permanent magnet motors. Your pioneering work. Glad to hear that. I hope somebody else will have some questions. Please switch on your mic and ask directly. That may be good to have other voices also today.
Hi, sir.
Yes.
My name is Anjali. I couldn't get the complete class of yours because of some connection problem. But I would like to ask you one doubt. Is the major impediment in this EV is the life of the battery itself, or are there any other impediments also in the research of EV?
Actually, I didn't even touch the life of the battery issue. The life of the battery is one of the issue, but I think the bigger issue today is the size and cost of the battery today. If you look at the Toyota Prius, which has been in the market for I don't know how many years, at least 15 years probably, the hybrid, I really didn't hear any issues with even that battery even today. So I don't know how they are managing that even for such a long time. Even our car batteries, we replace the car batteries in at least 4 or 5 years. You replace the car batteries. So I'm not sure how they are managing it, but I really have not heard any issues in terms of the life. Now so one of the huge market potential for if there are any entrepreneurs is probably the recycling of the batteries. This is going to become a huge issue as the electric vehicles become more and more prevalent, because what do you do with all these batteries at the end of the life? There are a lot of discussion on how do we, once the life of the battery is done from the car, because in the car, if the life of the battery became half, then it's not very good. So you could use that for other applications like renewable energy systems associated with solar systems and wind energy systems. You need batteries to store. So these are some of the discussions that are going on. How do we use this battery for some other applications? But still, at the end of the day, you need to be able to recycle these batteries at some point in time, and that will be a huge area of opportunity for some entrepreneurs.
Thank you, sir. Thank you.
So all along, it appears as though there's a lot of space for engineers, the budding engineers. And I hear from my students that they are interested in putting up a electrical vehicle, all parts, including some of the algorithms that are already there. Can you help us mentor to some extent?
I would be happy to mentor. Yes.
Oh,
I don't know
great.
how. They probably know better than me on all that stuff.
No. They'll be. In fact, in that case, I'll put them. I'll put them in contact with you such that you can mentor them, and then we'll have Dr. Tommy Sebastian mentoring and a group of students. That will be great for us. Thank you. So I'll still wait for questions, or else if you're tired, do we call it a day? Are you tired?
Oh no, I'm fine. I'm in the morning here. You guys are in the evening there. So.
You have given us a lot of energy, so I'm hoping that there will be some of the students will switch on their mic and ask something. In fact, they asked me whether they can get some help for putting up an electric vehicle, all the components. So now I'm happy to tell them that you will be there behind us. Thank you.
No problem.
Anybody has a question? Or a statement to make?
Hello, this is Sebastian. This is Manmohan from 79 Branch REC. Can you hear me?
Hi.
Hi, Sebastian, we're talking about batteries that reminded me of something. I have some interest in electric vehicles because I'm working in Abu Dhabi now. In fact, I just retired in Abu Dhabi and I was involved with electrical vehicle charging infrastructure to some extent. And in the meantime, I was always watching India and what's happening in India because that's where I'm going to return very shortly. And one thing that caught my attention is that Indian Oil, a company with which I worked a long time back, they have signed an agreement with an Israeli company and they're coming out, they're talking of an air aluminum battery. The biggest advantage is that it's not toxic, it's long life, and the raw materials are available within the country. We don't have to import lithium from China or anywhere. So have you any thoughts about air aluminum battery?
I have to say that I am no expert in the battery, so if I'm sure you know much better than me on that topic, so I would stay away from answering that one. I really don't know.
Neither am I an expert, but then it's fun to be in this atmosphere with all these students.
Maybe somebody from the somebody who is listening can answer that one. I think I won't be doing justice to answer that one.
Perhaps that will be a decision. Since your expertise is what we are trying to utilize today. Okay, so Krishna Prasad seems to have a statement.
Okay.
Yeah, but I missed it. Okay, yeah. Okay, I'll have to search the chat again. So meanwhile, if someone switches on the mic and says something, it will be good. In fact, I've been seeing quite a large number of messages right now appreciating the presentation. In fact, my sister appreciates you.
Thank you. Thank you.
Yeah, Krishna talks about a very important point you mentioned on the secondary life of EV. Everyone is talking about batteries, EV batteries. There are several projects, especially in battery energy storage systems, BESS, where such possibilities are being explored. That's right. That's right. As you said, several possibilities are being explored everywhere. And I also would like to say that, okay, though I'm not the person who's presenting, I would like to say that all the bits matter. All the bits that are happening in different parts of the world, all the small pieces of work that's happening in different parts of the world should come together to create a better electric vehicle, perhaps, because of all the good things that you have spoken about with respect to the electric vehicle, in terms of safety, in terms of comfort, in terms of emissions, especially with respect, in fact, with respect to every aspect of a locomotive.
Yeah, I think again the challenge is how do you bring it to an acceptable cost range so that people can afford it. So when a few years back GM came up with the Chevy Volt, I think Volt, yeah. So it was a hybrid vehicle. So but the equivalent non-hybrid version was selling for $20,000, and the Chevy Volt came up with $40,000 cost. I mean, that is not a viable situation. So it didn't go too far. I mean, there was for some time there was government subsidy and things like that. So, but it didn't go very far. So we have to address the cost. That is the only way this will become a reality. So. And that cost has to be in material cost reduction, manufacturing cost reduction, and of course the designs which are efficient to minimize the cost. I mean, these are all the elements which has to come together to make this happen. It is not just one area alone is going to make this happen. Okay. Thank you for all the great questions and discussion, and enjoyed it.
I don't know if there are more questions. Okay, I'll just sum up by saying that I think you have done the best that you can do, especially with respect to the youngsters out here. You have posed a large number of possibilities. I would say possibilities. as challenges. Though you call them as challenges, I would call them as opportunities for the young to take on, because ultimately the world is going to be of the next generation, and they are the persons whom we have to groom. And I'm very happy that you have given in your presentation the best of things that need to be given to the youngsters in terms of all the challenges, as also the golden words that this is the best time to be an engineer. Okay, in fact, I hope that the persons who are still in school, we learn that this is the time to be engineers, because there are quite large number of challenges, and it is definitely the onus is definitely on the youngsters to address them, and it is definitely, and if you take it in this spirit, everything is possible. Everything is possible. I suppose you have given that kind of message, and I believe quite a lot of appreciation is there for your presentation. And perhaps Anil will sum up by saying thanks to you.
Thank you, ma'am. Hello, sir. Myself, Anil. So thanks a lot for delivering this much wonderful section to each one of us.
Thank you.
Thank you, sir. Thanks a lot. And we will keep in touch with you for regarding the further projects, as Sudha ma'am said, mentoring and all. Thanks a lot, sir. From Vidya Academy of Science, on behalf of Vidya Academy of Science and Technology, I thank you to be proud to organize for such a program and a particular friends like you. Thanks a lot, sir. Thank you so much.
Thank you to all the attendees for sparing the evening with me. Thank you.
We had a wonderful time, and I believe that we will not spare you anymore. We'll be behind you to get the maximum.